For example 2, we are told that the region, which they're giving capital R to represent that region, is bounded by 3 lines. So we see the first line here is this oblique line. The y-axis and the x-axis are our other 2 lines. So this is the region that we're looking at here that we would call R. So on part A it says, what are the equations of the lines that define the bounded region? We know how to write the equation of the y and x-axis. We just reviewed that on example 1. A vertical line is always x equals whatever the x-coordinate is for every point on that line. So for the y-axis, we have, I'm going to put this answer over here, the y-axis, its equation will be x equals 0. The x-axis is when all the y's have the same number. So horizontal line is always a y equals equation. Every single point on the x-axis has a y of 0. This is 1, 0, 2, 0, 3, 0, and so on. So the equation of the x-axis is y equals 0. Now this line we have to use, again, some Algebra 1 skills to remember that we write equations in the form y equals mx plus b, which requires us to know the slope of the line and where it crosses the y-axis, which we call the y-intercept. Well, the y-intercept is really easy to see. We can see this line crosses the y-axis at 4. So that tells me my b value is 4. The easiest way to find slope when you're given the graph is just to look at the rise over run, but you need 2 points to do that. Well, we have 2 points. We have the y-intercept, and we also see that it crosses the x-axis at -5. So we can find our rise over run to go from point to point. To go from -5, 0 to 0, 4, I have to go up 4 units and over to the right 5 units. Okay, so this is my rise of 4. This is my run of 5. So rise over run would be 4/5. So this equation would be y equals 4/5 x plus 4. Rise over run for slope and my y-intercept. Okay, we can tell it has a positive slope since it's going uphill. So that helps you to check and make sure your sign of your slope is correct. So now we're ready to find the perimeter of that triangle. So remember, we're just adding up the lengths of the sides. 2 of the sides are very easy to find the length of. We have our side here that's a vertical line, which we know is just 4 units. And we have our side here, which is a horizontal line, which is just 5 units. This is not a Pythagorean triple. We don't have a 4, 5, and a whole number to represent this side here. So we're going to have to find that, which would be the hypotenuse, using the Pythagorean theorem. So we know our 2 legs are 4 and 5, so we would do 4 squared plus 5 squared equals that unknown side squared, which is our hypotenuse. So we have 16 and 25, which add to get 41, and we know to find that side we have to undo the squaring by taking the square root. So that side has a length of square root of 41. We're not given any rounding instructions, so we'll just leave it as the square root of 41. And that doesn't simplify since 41 is a prime number. So now to find my perimeter here, I'm adding up the 3 sides. I have 5 plus 4 plus the square root of 41. Now remember, you can only add like terms. So I can add the 5 and 4 to get 9, but I can't add 9 with the square root of 41. So my perimeter is just 9 plus the square root of 41, and that's linear units. To find the area, since this is a triangle, we find the area of a triangle as 1/2 base times height. Remember, base and height have to be perpendicular. Well, a vertical and horizontal line always create a right angle relationship, so I'm going to be using these 2 sides of the triangle as my base and height. Remember, your height's not always a side of the triangle. That only occurs when it's a right triangle. So since we have a right triangle, 4 would be my height, 5 would be my base. So I'll have 1/2 of 5 times 4 5 times 4 is 20. Half of that is 10. So we'll have 10, and my units would be squared since we're talking about area. So part D says, draw and describe the geometric solid formed by revolving the region around the y-axis. Okay, so I'm going to go over here and I'm going to redraw this triangular region. So one end of my triangle is at the origin. I have another vertex at 0, 4. I have another vertex at negative 5, 0. Okay, so I just plotted this point, and this point, and now I can draw that triangle that represents the region I was given. Now, pay attention to what you're revolving around. Y-axis. This is our y-axis, so we're revolving around this way. So the first thing I'm going to do is reflect across what I'm revolving around, which is reflecting across the y-axis. So since these points are on the y-axis, remember they won't move. The only point that moves is this one right here. It's at negative 5, 0. It will reflect over to 5, 0. So as this is revolving around, remember we've got this flat circular base that's formed down here at the x-axis. So this figure that is formed has a circular base that comes to a point up here. So what is the name of that describing geometric solid? That is a cone. And to describe it, we're going to give its dimensions, its radius and its height. So from here to here represents the diameter of that circular base. So the radius is only here to here, which is 5 units, or here to here, which is 5 units. The height will go from here up to here. The height of that triangle is the height of the cone. 1, 2, 3, 4 units is my height. So now I have drawn and described it. Now I'm finding the volume of the solid in terms of pi. So the volume of a cone is, remember, 1/3 of the volume of a cylinder, which is base area, pi r squared, times the height. So I'll have 1/3 of pi times 5 squared times 4. 5 squared is 25. 25 times 4 is 100. 100 is not evenly divisible by 3, so I'm going to leave that as a fraction, 100/3. I can't forget my pi, and since we're finding volume, my units would be cubed. Now part E says, will the volume of the cone formed when region R is revolved about the x-axis instead of the y-axis, would it be greater, less, or the same? So we don't have to draw it, but we need to think about it. So if I took this triangle and I revolved it around the x instead of the y. Now let's think about what our radius and our height would be of this new cone. Okay, the radius, since we're going this way, now my circular base is here on the y-axis. So my radius would be 1, 2, 3, 4 units. My height would go from here to here. This is now the apex of the cone. So we have 1, 2, 3, 4, 5 for the height. So the radius and height switch places when you revolve around the other axis. Since it's touching both axes, that's what we can look at. So since we square the radius and we don't square the height, if you have a bigger radius, you're going to have a bigger volume. Right? So here we switched the 4 and 5. So now the 4 is being squared, and then we're multiplying by the 5. Well, 5 squared times 4 gave us 100. 4 squared is 16. 16 times 5 is only 80. So we'd have 80/3 pi units cubed. So since the radius is smaller, and it is the dimension that is squared, the second cone has a smaller volume than the first cone. since the radius is smaller and it's the dimension that gets squared in the formula for volume, that means the second cone has a smaller volume than the first cone did.